Hello everyone. Today we are going to study mechanical properties of fluids, the derivation of Bernoulli's theorem. What is Bernoulli's theorem? For any streamlined flow, the sum of pressure energy per unit volume, kinetic energy per unit volume, and potential energy per unit volume remains constant. At first, we will talk about what is kinetic energy per unit volume, potential energy per unit volume, and pressure energy per unit volume. Kinetic energy per unit volume. It means kinetic energy upon volume. Kinetic energy's formula is half mv square and volume is v. This v square is velocity and this v is volume. We know that half m upon v square. We know that m upon v is density, that is half rho v square. That's kinetic energy per unit volume. Now we'll talk about potential energy per unit volume. Potential energy per unit volume is potential energy upon volume. Potential energy, we know that mgh and volume is v. We know that m upon v and g will be here. M upon v is rho, is rho gh, which is, we know that rho g is the gauge pressure. Number 3 is pressure energy per unit volume. Pressure energy per unit volume, we know that pressure energy is PV and per unit volume is V. V is V, it will be only P. Here M is mass, V is volume, V square is velocity, rho is density, G is acceleration due to gravity, H is height, and P is pressure. According to Bernoulli's theorem, Bernoulli's theorem, P plus half rho v square plus rho gh will be constant, or we can say that P1 plus half rho v1 square plus rho gh1 is equal to P2 plus half rho v2 square plus rho gh2. We have to prove this and this. We have to prove this equal to this. At first, we have to draw the figure. Let me draw the figure. I will cut the video here and I will draw the figure and then you can draw. Okay, you can draw with me. I am not cutting the video. Okay, let's make a straw, or we can say which can pass a fluid. It will be like this. On a streamline flow, it bends somewhere. Okay, this area is A1, this area is A2, coming velocity with V1, going velocity with V2. This will be the ground level from where the height will be measured. The height will be from, this will be H1 and this will be H2. H2 is greater than H1. Now let's prove it in the next page. We know that change in kinetic energy is equal to change in kinetic is equal to half m v final square minus half mv initial square. This is equation 1. Change in potential energy is equal to mg final h2 minus mg initial. That is equation 2. We know that delta work done is equal to minus W2 minus W1. If we uh, change the sign, it will be W1 minus W2. We know that delta W is equal to P1V minus P2V. It will be our third equation. Now we all know that according to law of conservation of energy, according to law of conservation of energy, delta W is equal to delta kinetic energy plus delta potential energy. Now we have to all add this. P1V plus half mv1 square plus mgh1, sorry, we have to do at first P1V minus P2V, that is delta W, is equal to, we have to write delta kinetic energy, that is half mv2 square minus half mv1 square plus mgh2 minus mgh1, which is delta potential energy. Now take all the v1 and h1 on left side and p2 in the right side. It will be p1v plus half mv1 square plus mgh1 is equal to p2v plus half mv square v2 square plus mgh2. Now we will be dividing the whole equation by v. Dividing the whole equation by v. It will be p1v upon v plus half m upon v v1 square plus m upon v gh1 is equal to p2v upon v plus half m upon v v square plus m upon v gh2. All the v's will be cutted, p1v p1v. It will be p1 mv is rho half rho v1 square plus m upon v is rho gh1. Same on the other side, p2 plus half rho v2 square plus rho gh2. Now the equation is proved, that is p1 plus half rho v1 square plus rho gh1 is equal to p2 plus half rho v square plus rho gh2. Also we can say that p plus half rho v square plus rho gh is equal to constant. It will be constant. From this equation we can say that from Bernoulli's theorem we also know that fast moving fluid creates low pressure. Write a point that fast moving fluid creates low pressure. Whenever there will be a fast moving fluid which will be creating a low pressure. Let's write some applications of Bernoulli's theorem. Applications on Bernoulli's theorem. Swinging a ball. And second is flying of aeroplane.